Liquid-liquid extraction is a process of extraction a solute from a feed by using a solvent to produce an extract and a raffinate. Why use LLE, not distillation? Okay, LLE is used when the required solute to extract from the feed has almost similar boiling point with the carrier, while the distillation has higher process cost than liquid-liquid extraction because use of heating process in the distillation process. So, LLE is more preferred than distillation in industry. The simplest liquid-liquid extraction involves three components: solute, carrier and solvent. The solution which is to be extracted is called the feed. The liquid within the feed is called the solvent. The solvent rich produce the operation is called the extract, and the residual liquid from which solute has been removed is raffinate. The first application of the liquid-liquid extraction is in the biomass technology. The example of it is the removal of high-boiling organisms from the wastewater such as phenol, aniline, and the nitrated aromatic. The second application is the extraction of the metals. The example is the extraction of the cobalt from the hydrochloric acid using aniline 336 in methacillin. The third application of the liquid-liquid extraction is in the food industry. The example of it is the separation and purification of flavor or fragrance, as well as the caffeine extraction. For the liquid-liquid extraction principle, the feed phase contains a component I which is to be removed. The addition of a second phase, which is solvent, is immiscible with feed phase, but component I is soluble in both phases. Some of the component I solute is transferred from the feed phase to the solvent phase. Normally, one of the two phases is an organic phase, while the other one is an aqueous phase. Under equilibrium condition, the distribution of solute is over the two phases determined by the distribution of the law. After the extraction, the two phases can be separated because of their immiscibility. In liquid-liquid extraction unit, a liquid stream which is carrier containing the components to be recovered is fed into an extractor where it contact with a solvent. The two liquid must be immiscible or only slightly miscible. This allow them to form a dispersion with the liquid dispersed as droplet in the other. For the extraction, for the batch extraction, there are single stage and the multi-stage. For the single stage, the solvent and the solution are in contact with each other only once, and thus the raffinate and extract are in equilibrium only once. For the multi-stage counter-current system, the solvent and solution which flow opposite the counter-current to each other come into contact more than once and mix on stage inside the reactor.
The advantages of liquid-liquid extraction are very large capacity are possible with a minimum of energy consumption. Second is selectivity, when other standard separation methods such as rectification fail or require expensive equipment or energy costs. Third, heat-sensitive products are processed at ambient or moderate temperatures. Lastly, separation of small contents of high boiling impurities, mostly in aqueous solutions. In the normal thermal separations techniques, the complete water content has to be withdrawn by a very energy-intensive evaporation process.
Duduk kau gelap lah.
Dia gelap.
Nice tu ah. Gelap cinta.